Hello everyone, continuing our methods of integration series, in this video I'm going to explain the general exponential rule for integrals. So if you have integral of e raised to power u du, so that is equal to e raised to power u plus c. So where u is function of x. So we know that derivative of an exponential function is the function itself. Similarly, the integral of an exponential function is the function itself. So just an alternative form of this formula would be, so if you have u equals to fx and we're going to write everything in terms of fx, so it means du over dx is f prime x, so derivative of the function. So differential du is equal to f prime x dx. So our other form of the same formula becomes, so e raised to power u means e raised to power fx. So in place of du, we can replace that by derivative of fx dx. So this together is called differential of the function. So this is our differential of fx. So here we have e raised to power the function times differential of the function. So this integral form is equals to e raised to power the function plus c. So that's how we're going to recognize the form in our problem. So integral of e raised to power some function times differential of the function is equal to e raised to power fx plus c. So let's use this in some problems. So let's try integral of, so 5 we can take outside. So integral of ex dx, and we know that. So here we have e raised to power some function. Function is x, and the differential of that function is dx. So it means, so answer should be, so 5 as it is. So this integral is equal to e raised to power x and plus c. So this was very simple, right? Because we have simply x. But what if we have something else? So here we notice that we have x square on the top, so e raised to power x square and 2x here. So in our mind, we think that, okay, so the power is x square, so that is our function, and the derivative of x square is 2x. So we have this form, integral of e raised to power fx and the derivative of fx dx. So it means in one step you can write your answer. So this should be e raised to power the function, which is x square plus c. So that should be our answer. But if you like the longer method, so you can write the solution step by step. So other way of writing this solution is, let u is equal to x square. So whatever you have on the top of exponent, right? So exponent on e, so that power we put as u. So from here du is equal to 2x dx. So our integral becomes e raised to power u du. So that is e raised to power u plus c. But since our u is x square, so e raised to power x square plus c. So it doesn't matter how, in which way you want to write your answer. So you can just write that in one step, or you can show your work by doing u substitution. It's basically the same thing. All right, so let's look at more examples. So we have 4 times e raised to power x square, x raised to power 5 plus 6x square. So if we think of this as our function, and let's bring 4 outside. So e raised to power fx, so that is our function. And then we have the differential of the function. So derivative of x raised to power 5 is 5x4 plus 12x. So derivative of this function is here. So this is our, and then we have dx along with it. So this is our differential of the function. So it means we can simply write this as, okay, so I'm just going to write this as e raised to power x5 plus 6x square times 5x raised to power 4 plus 12x dx. So we have e raised to power a function, differential of the function. So answer should be e raised to power the function itself plus C. So that is our required solution of this problem because we recognize this form. So you have e raised to power some function and you have differential of the function. So answer is simply e raised to power fx plus c. So this is our general exponential form. So in this example, we have e raised to power 3x cubed 3x squared dx. So our power is 3x cubed. So if we think about it, so u is equal to 3x cubed. So du over dx is 9x squared. It means the differential of the function is 9x squared dx. And we have 3x squared dx here. So can we make 9? Yes. So in order to make 9, we need to multiply by 3 here. And in order to balance that, we need to divide by 3. So in the next step, we notice that our integral becomes 1 over 3 e raised to power 3x cubed times 9x squared dx. So now we have e raised to power some function. So that's our function. So this is our differential of the function. Differential of the function. So in this case, it should be 1 over 3. So integral of this would be e raised to power fx, which is 3x cubed plus c. Alright, so now I'll show you the other way of writing the same problem. So if you want to figure out this integral, so another way is so you can start with what is given to you and we can use substitution method. So we're gonna do step by step. So first we use u equals to 3x cubed. So du should be 9x squared dx. And from here, so since when we do the substitution, we need the value of x squared dx. So du over 9 is x squared dx. So now our original integral is going to be replaced by the new one. So e raised to power. So in place of 3x cubed, we write eu. And in place of, so 3, we can just take it out. And in place of x squared dx, we write du over 9. And then, so we have 3 over 9 integral of eu du. So this integral is, so 1 over 3. So this integral is e raised to power u plus c. And then we plug back the value of original in terms of original variable. So we get e raised to power 3x cubed plus c. So some teachers prefer like you show them step-by-step work. So that is the other way of writing the same problem. Or you can simply use the shortcut method where you recognize the form and you can write your solution. So the gist of this video is that if you have some integral of the form e raised to power the function, derivative of the function dx, then the answer is e raised to power fx plus c. And what we learned before this in the previous video was if you have something of the form 1 over fx and then derivative of that function, so that is our logarithmic form, ln of fx plus c. So these were our two results, two forms that we have learned so far. So this is our logarithmic form and this is our exponential form. I hope you liked this video. So if you're interested in more work around integrals, do watch the other videos as well. Thanks for watching. See you next time.